Now that we know what an ideal gas is, we can start looking at gas laws. Gas laws predict gas behavior, and by gas behavior, what we mean is the relationships between pressure, volume, temperature, and the amount of gas. So in other words, I can say I have this volume of gas at this temperature and this pressure. How many moles of gas are in that container? Anyway, so the first gas law we're going to use is the ideal gas law, and it's a simple one that applies whenever those assumptions on the previous slide are reasonable assumptions. Okay, and so the thing to know about the ideal gas law is that the units are very important. You have to have the right units that go into it. So let's talk about each variable here in the ideal gas law. P, of course, is what we use for pressure, and it must be in atmospheres. V is what we use for volume, and it must be in liters. N is moles, and it is in moles. So the ideal gas law works with not the grams of the gas, but with the number of particles. It's based on particle behavior. Then R is a constant. And it has all of these units that come with it. We'll talk about that a little more in a second. Temperature has to be in Kelvin. It's important that you have an absolute temperature scale because kinetic energy is directly proportional to temperature if it's in absolute temperature, but it's not if you're, say, in Celsius. And what that means is that if you have something at 50 degrees Celsius and you double its temperature to 100 Celsius, its kinetic energy has not doubled. But that's true with Kelvin. If you go from 50 Kelvin to 100 Kelvin, the kinetic energy has doubled. And that's because it's based at absolute zero, and mathematically it works out. A little bit about this ideal gas constant. It has all of these units because it has to go with what else is there. It's kind of like you could think about it as a fudge factor. It's actually derived mathematically, but the units have to match the other units that you're using in order for things to cancel correctly. If you were to use a different unit for pressure, say, you would need a different value for R. It wouldn't be 0.08206. And then a note is that an ideal gas law, we say it obeys this equation, and obeying means that it gives you accurate numbers. Like if I put in the pressure, volume, and temperature and I solve for the number of moles, is that accurate? Well, if the gas obeys the ideal gas law, then it is. And it will obey the ideal gas law if those assumptions that we made for the kinetic theory are decent assumptions. Okay, and note that when you're dealing with ideal, non-ideal conditions, there are different equations that can be used, and we're not going to use any of the non-ideal ones. Okay, and this is just a summary before we do some examples of what can go in here.